I'm going to talk about a way of using Angular that's probably a pretty unusual one, which is to use it to create music. So this talk is really about this curious intersection between two different things, music and web development. And these are both kind of great passions in my life, but which I'm sure is true for many of us here, but I don't think it's quite that common to actually try to combine these two in any way. And certainly it hasn't been a thing for me for most of my life until actually very recently. It wasn't until this year that I started to, well, first of all, discover that there actually is an intersection between these two things, and secondly, to try to actually explore that. And there are a couple of reasons why this is something that I'm doing now. And one of them is really a technical enabler of this whole thing that makes it possible to have an intersection between web development and music, which is web audio. Because now that there is a web audio API that's been standardized and deployed across all the major browsers, we as web developers have a way to synthesize and process sounds and potentially to make music with that right inside the web browser. It's great for someone like me who's a web developer because although programming environments for music have existed for a very long time, they've never been quite disconnected to the stuff I do every day. Because I'm a web developer, I spend a lot of time and energy figuring out how to do stuff in the browser. So if I can use those skills and those technologies I have in the browser to actually make music, that's a lot more accessible to me than something that's completely foreign to that. So this kind of makes it easy to get started with musical apps for web developers. But the real reason I've been doing this, though, is not the web audio API. It's really more personal than that, which is kind of my growing interest in generative music systems, because that's kind of something that really grabs me. And what I mean by generative music is this idea of creating music, not by composing music, nor by performing music, because as you heard, I don't know how to play anything, but by actually creating systems that then make the music for you automatically. And there's a long history of humans making systems like this. Wind chimes, for example, are a system that has existed for thousands of years that makes music. And there's a whole history of these kinds of generative systems and experimental music made with them across the ages. And coming back to the present, these days, for example, many games have procedural or algorithmic music systems in them. So there's a lot of this kind of stuff around. And what's really interesting to me about this is that this kind of music making lends itself to software really well. And as someone who doesn't know how to play anything but does know how to make software, this sounds good to me because I can maybe, even though I can't make music, maybe I can make systems that make music. That's kind of an indirection that seems plausible to me. So that's what I've been trying to do using web audio lately. And today there is this one particular system that I would like to discuss, which originates with the American West Coast composer, Terry Riley, who is kind of one of the leading figures of Western classical music of the 20th century, especially the so-called minimalist school of classical music. And he has done a lot of things over the last 50 years, but there's this one thing that is especially interesting, not just as a composition, but as a generative system as well. It's called In C. It's something that Riley made when he was quite young in the early 60s. And it's a kind of a piece of classical music in that it has a score that has been published that you can read and perform from. But it's a very unusual musical score because it only actually contains one single page of music notation. And on that page there are these 53 numbered patterns, tiny melodic patterns of music. So there's not much musical material here at all. But even though there's not much, when you play this piece, you usually get more than an hour of music from it. And that is because accompanying this notation, there is this set of performing directions written that outline a certain way you should play or interpret that score. And you can play this piece of music with any orchestras, with any instruments, any sizes of ensembles, but there are a couple of important rules you need to follow. One is that every player playing the piece must play all those 53 patterns in the same sequence, starting from number 1 and ending up on number 53 in the same order. But crucially, every player has this freedom to keep repeating any given pattern for as long as they want. So when you're playing this, you can go through all the patterns, but you can stay on each one and repeat that for as long as you feel like it. So every player ends up having their own kind of timeline based on how long they want to stay in certain places and how fast they want to go through it. And this is the generative element in this piece, because this means that if we consider just 2 players playing this piece of music, they're both going to start on number 1. But there's going to come a time when one of those players makes a decision to jump onto pattern 2. And suddenly what happens then is we have 2 things playing on top of each other, which wasn't written down anywhere, wasn't in the score really. It just happens at runtime based on the decision made by this player. And then at some point the second player might also jump onto pattern 2, and then again they're both playing the same pattern, but because these patterns have different durations as well, they're gonna be drifted apart at this point and won't be playing in unison anymore. And here we already see that from this extremely simple source material and from these very few rules, we get this emergent complexity. That's the result of these players making these decisions at their own, when they feel like it, and then we get this layering that's unexpected, that wasn't planned ahead. And that's why the kind of music generates itself in a new way every time it's played. And one way to look at that is that this is really not just one musical composition. It's actually this whole landscape, this whole universe of possible compositions. And every time you play it, a new path is taken through that, a new piece of music is created that no one has ever heard before, and no one will ever hear again unless it's recorded. So even though In C has been performed for thousands of times in the last 52 years, there's never been 2 performances for exactly the same succession of notes because of all these freedoms involved. And to me, as someone who's not musically educated, this just blows my mind, because it doesn't kind of fit in my brain. How can there be a piece of music like that? How can there be so much freedom built into something, but still, if you listen to 20 different versions of this on YouTube or somewhere, you'll instantly recognize each one as this composition. But the other thing that I really find interesting about this is I can look at that notation and I can look at the instructions and recognize that this is actually a system as well. So there are algorithms and rules governing how this thing works, and that is something I can maybe work with in software. So that's what I've been doing. I took that score and I translated it into a JSON format that has that same information as the notation has, but in a format that I can work from in code. And then I wrote this little application that sort of brings that score to life. So this is an application you can run inside your browser to play this piece of music for your own entertainment. And the way it works is that when you start playing it, you are accompanied by these 5 bot performers. And these bots will all carry their own instrument that they contribute the music, and they will play the music for you, but what you get to do as the user is conduct this bot orchestra. So you can choose when each of these bots joins the music, for example. And then you choose when these bots move on from one pattern to the next, because they always keep repeating the same thing until you click them over to the next thing. And that's how you bootstrap the piece. And then you just click your way through the composition, to kind of generating your own version of it that no one has ever heard before. And as you do that, you get into these very different places that may be built from extremely simple melodies, but they get more complex when these bots arrive at them at different times, and we get that layering that adds the complexity to the music. That's the application. And this runs in your browser, and you can use it in any modern web browser, and it uses the web audio to play the sounds, and it uses some canvas things to make the visuals. And it is an Angular application, otherwise I wouldn't be here talking about it. And it's built in this reactive way that uses RxJS and the ngrx family of libraries as the kind of architectural basis. And well, here's how the whole thing works. At the center of this whole application, there's this one thing that's really the most important part of all, which is the application state contained in a single data structure. And that contains really everything you need to know about what's going on in the application at any given time. Who's playing the music? What are they playing right now? What are they going to play next? These things are all in that same data structure. And it is an immutable data structure, which means that we never change it when we want to change things. Instead, what we do is we produce new versions of it using this function called a reducer function that takes a state value and an action that represents something that happens in the world and produces a new state and returns it as the next state. So it's a pure function that takes these arguments and returns a new thing. And as we go and apply this reducer function to many states over time, we get this sort of timeline of state values that the kind of state takes over time. And this is something that is actually easily modeled as an observable, because observables are a great way to model something that takes on different values over time. And so our state is actually an observable of this thing. And if we take that observable then and wrap it inside the same object with the reducer function, we get this thing called the store. So this is the ngrx store pattern, the combination of the state modeled as an observable with the reducer that operates on that state. And that's very, very similar to Redux, for example. And what we can do with that is we can dispatch these actions to it, and it will apply the actions to the state using the reducer function, and then emit those new states on the observable. And that sort of forms the functional core for the application. But by itself, it doesn't really do anything. It's just a data structure and a function lying there until we actually connect them to the outside world in some way. And the thing where everything really springs from in this application is something called a pulse. And that actually comes from the score of in C, where Terry Riley describes that when you play this, there should always be one person, one player playing high C notes on a piano with a steady tempo throughout the whole performance. Because that provides kind of a rhythmic grid, a steady tempo for everyone else to play against, so that they are all in sync. And you can hear that in this application as well. I have it playing there at the background. But more importantly, I actually use the concept of the pulse to kind of drive the rest of the music as well. So how that works is that I have this little pulse service in the application. An Angular service called a pulse service that hosts this little metronome object. And that metronome produces a steady stream of ticks over time, metronome ticks, as an observable. And what I do with those ticks is I map them into pulse actions using the RxJS map operator. And then I actually feed those pulse actions into the store using ngrx effects, which has this effect decorator. So what this means is that I'm effectively dispatching a pulse action to the store at a steady time interval. And from that, the store will then react accordingly by producing new application states, because the store has an action handler for the pulse action inside the reducer, where we make decisions like, what is everyone going to play right now? Are some of the players going to repeat the current pattern or move on to the next? All these decisions are made as a reaction to the pulse action. So we're effectively sequencing the music live with this pulse cadence, and that's how it gets kind of composed. But by itself, this is not something you can hear yet, though. The music is still just a data structure inside the store. We need something more to actually pull it out to make it audible. And that something in this application is something called an audio player. It's another Angular service, which also has an ngrx effect in it. But this effect is a bit different from the pulse in that it doesn't actually dispatch actions to the store. It merely reacts to actions dispatched by someone else. So after every one of those pulses, this effect will grab the latest state from the store, which is just an observable, and it will then play whatever sounds need to be played based on that state. And here it'll use the Web Audio API to essentially play certain samples of certain notes on certain instruments. But it doesn't make any decisions about what to play or when to play it. It's a fairly simple service that just plays what the state says should be played. It just deals with the implementation details of how to actually make noises with the Web Audio API. but it's modeled as a side effect of the store. So now we have two side effects, one input and one output. When we put all those together, kind of pipe them together using observables, we have a system that you can actually listen to. But this system is still missing one piece, which is, well, everything you can see on the screen, the actual UI of the application. And this part, unsurprisingly, is just an Angular component tree. This is, after all, an Angular application. And the way that works is that we have the single root component in the application, as you usually do in Angular apps. And into that root component, we inject that store object that I've been talking about. And then we use the select operator that comes with ngrx to select certain parts of the state that are interesting to us in terms of the UI. And we get observables of those parts of the state. And then in the root components template, we actually subscribe to those observables using the Angular async pipe that Ben was talking about earlier. And so here, effectively, we are subscribing to the store because these observables are derived from the store. And what that means is that for every one of those pulse actions, for example, whenever the data, the values changes inside the store, we get new data flowing into the Angular component UI through these subscriptions here. And then the application has a bunch of other components, but those are all these kind of stateless or pure or dumb components, however you want to call them, that don't know anything about observables or stores. They just get whatever they need using Angular's data binding as pure data structures as inputs. And that way we kind of trickle the data down the component tree using nothing but inputs. And then turning that around, when the user initiates an event, we get these events that we trickle back up the component tree using component outputs. And when we reach the root component, there we, based on those events, dispatch actions back to the store. So that's how the root component ends up having a bidirectional relationship with the store, because it not only subscribes to it, but also dispatches actions back to it. But the rest of the components don't know anything about this. They just deal with data and events, inputs and outputs. And, well, that actually completes the architectural picture. This is what the system looks like. So it has these four things that I think form a pretty good set of primitives for any musical application, because you need something to model time, because music is something that happens over time. You need some core logic to kind of make your music itself. You need something to make it audible, and you need something to control it and to make it visible. And I have these here, and I have them in a very decoupled system here, where they don't know anything about each other. They're just wired together using observables at runtime. And this kind of architecture happens to make certain things pretty easy to do that I would like to mention. And a couple of them have to do with just developer productivity. And the most important thing, really, of everything is hot loading. So I have a setup in this project where I can make changes to the code while the app is running and have those changes applied without having to start from the beginning, which is fairly important when you're like 20 minutes into the music somewhere and you need to change something about how it looks or sounds. You don't want to kind of find your way back there every time. And this is something that I can do even though Angular itself doesn't really have any hot loading features. And that is because of this architecture, because it makes it really easy for me to kind of do my own hot loading. And that has to do with that state, because as I mentioned, that state is really the only interesting thing here. It completely describes everything that is going on in the application at any given time. And what that means is that when a code update situation occurs, when Webpack tells me that the code has changed, that we are going to have to do a reload, all I have to do is grab that state from inside the store and then hold on to it while I let the application reload. So I'm keeping the state, but then I let the application get destroyed. I let a new one load with the new code, but when it loads, I drop in that existing state to the new version of the application. Because immediately what happens there is that the same music resumes playing, the same visuals resume rendering, because they're just derived from that state, and I kept the state. And so this is effectively hot loading. It's kind of cheating my way into it, because I'm not actually doing hot replacement of code inside a running Angular application. I'm actually fully reloading an Angular application. But the thing is, I don't really care, because as an application developer, I can just continue working, because it's as if it was hot loading, and I can just keep staying in the place I was in and make these code changes. And that's a fairly nice kind of effect of using this kind of state management. And that is actually very important when you're working on an application like this, because I don't know about you, but I have 100 different ideas when I'm working on something like this, most of which are going to be terrible ideas. But the thing is, I don't know which ones are good, which ones are bad, before I've kind of tested them out. So I need feedback loops to kind of guide me through it. I need to be able to quickly test ideas, discard them, keep some of them, and then move on to the next idea. And this is something hot loading can help with, because it provides this quick feedback loop. And this is something we can do with Angular today, at least if we do it with this sort of approach. Now, the other developer tool I then have in here is something I don't use quite as often, but is also pretty useful when you do need it. And that is this little slider component at the lower edge of the screen in developer mode that lets me travel through time. So at any point, I can grab that slider and drag it back into the past to some value that was there, say half an hour ago. And then I can drag it back into the future again. And that ends up being pretty useful when, for example, I make a visualization change and I want to see how that affects different parts of the composition, because it might be very different, and I really don't want to kind of click my way through the whole application, the whole composition for every change I make. That's pretty useful, and it also kind of just falls out of this architecture. And again, it has to do with how that state works. Because the other thing about that state is that it is an immutable value, which means that when we make those new versions of it using the reducer function, we are not destroying the previous values, which is what would happen with a kind of regular mutable object graph. So what that enables then is we can ask our developer tools, the ngrx developer tools, to keep the old states around, the historical states around in memory. We can have a whole history of states in there as we're developing, and then we can effectively scroll through it and take any historical state that's in there and reuse it, drop it back in as the current state. Because again, what will happen there is that the music and visuals from that state will start generating. So it's as if we jumped to that point in time. So these are kind of the benefits of modeling your state as a centralized immutable value. You get these kinds of developer tools, and all of this is probably very familiar to anyone who's used Redux and React before, because it kind of comes from there. But there's this one more thing that I would like to mention about this architecture, which is that it also seems to be very open for extension, very easy to extend to new things. And one example of that is that when I tweeted about this project, when I was still in the middle of it, this guy Christian happened to see that tweet. And he works in IoT, and he has a lab back in Amsterdam where he lives with, among other things, a set of physical controllable lights in that lab. And he had this idea of maybe we could make this application and the lights kind of work together. And so we did that. We made my Angular application control the lights in his lab, me sitting in Helsinki and him in Amsterdam. And we effectively made this light installation based on this Terry Riley composition, which is something that I never expected to do, but just happened because of Twitter. And well, the neat thing about that, really, from the perspective of this conversation here, is that adding that integration was just a matter of adding one more service into the project, one more ngrx effect. I didn't have to make any changes to the existing code, the core logic or anything, just adding one more output, which is kind of a good sign for me that this application can be easily extended with new things. So I was able to add this new integration without having to change all the existing code. And I think it's because of this architecture, because these four things here are fully decoupled from each other. They don't know that even about the existence of each other, which means that I can, say, add one more output next to the UI, which is the light controller. I could do other things like replace the pulse metronome with a MIDI signal, for example, or kind of do all kinds of things without the rest of the system really caring that had happened. And that makes me optimistic about where I can take this application as well as future applications I might make in the same way. But yeah, that's that application. If this tickled your interest, There's a live demo on my website in that URL. You can use that to play the music for yourself in your browser, as long as it's not IE, because that's the browser that doesn't support web audio. And if you want to look into the code, that's on GitHub. I have a project there where this application lives, and it's a completely standard Angular Webpack project that you can just and start playing with. And that's it. Thank you. Looks like I do have some time for questions if you have any, so happy to answer any what you might have. Please. Any other, you mean compositions like that? Not exactly. There aren't any in that exact same way, but you could definitely use the same system. Actually, I'm working with a friend who is an actual musician to maybe try to put our own composition in there. I'm not musically kind of sophisticated enough to be able to do that because you have to understand harmony and things, because these things may combine in all kinds of different ways that you might not expect. But he is a musician, so we're trying to kind of make this same kind of system, the same rules, use a different score essentially, different notes, different patterns, and different instruments as well. So yeah, it's an interesting thing to explore. It was probably, yeah, the question was what was the most difficult part of working with ngrx here. It was probably figuring out how to do the time travel and things like that, because the libraries keep changing, because especially those parts of it are very kind of changing all the time at the moment. They're in alpha. And actually, something I didn't show here that became possible after I did this is that they made the ngrx store compatible with the Redux developer tools extension for Chrome and Firefox. So that's something that has even more sophisticated kind of time travel features that you can actually use with ngrx. And well, making that work was also kind of challenging, because both Redux developer tools extension and ngrx make several releases each week at the moment, and they mightn't be in sync all the time. So kind of the newness of those libraries was a bit challenging. But they are quite small, the libraries, so you can actually go and look at the code and kind of understand it pretty easily. Yes, please. You mean the performance of how much music can you play? Yeah, that's an interesting question. I use 5 players here, and the Terry Riley score describes that you could have as much as 35, which is a lot more. There are a couple of reasons why I didn't go there. One is that I don't have the musical arrangement skills to make it sound not horrible to have that much playing at the same time. But the other thing is that I do run into performance issues, especially on Apple's mobile devices with web audio. So even though I have an iPad Pro, which is a kind of multi-core, most powerful iPad there is, you get this kind of distortion when you add more than what I have in here at the moment. As soon as you have anything else going on, for example, so when you click, you might get some distortion. Because Apple's web audio implementation is not as good as the other ones are at the moment, and I hope they'll improve it. But yeah, the kind of native audio processing capabilities of the browser become kind of the bottleneck when you add more.